Welcome to this demo of VideoCoin Symphony, where we're demoing our scalable blockchain infrastructure. And this is part of our alpha release that just happened yesterday. And then you'll see more from our alpha release coming over the next few days. But in this demo, you'll be meeting also our blockchain team with Ricardo, Jonathan, and Adrian, presenting all the great work that they have done also through these demos. Before we get into the demos itself, a quick overview of the agenda itself. We'll do a quick introduction of what VideoCoin Symphony is, and then we'll do a deep dive of the architecture, and then we'll do the demo. So VideoCoin Symphony is a scalable, secure, and reliable access to the VideoCoin blockchain. I mean, like all of us here have used blockchain in different ways, right? Some people use blockchain by installing a full client. Some people use a light client, and most people prefer to use an interface, a scalable interface, which was made popular by blockchains like Ethereum. It has a very scalable and really good interface through Infura. In fact, most of the enterprise customers want an interface like this as opposed to a full client installation or a light client installation, because imagine trying to have reliable access to your blockchain and suddenly your light client lost a bunch of peers and then it's no longer able to confirm transactions. And you have this really important video stream going on. Let's say you're streaming a game, a soccer game or a football game, and suddenly you can no longer write transactions to the VideoCoin blockchain because your clients are not responsive or have lost peers. It becomes a massive challenge to businesses to use blockchain. So that's why most projects, most companies expect to have a reliable access to the blockchain, and VideoCoin Symphony is our way of doing it. So VideoCoin Symphony provides a portable access to the VideoCoin blockchain, so you really don't need any clients. You can just access the blockchain using an RPC call through standard authentication methods. And the most awesome part about the way we have implemented the Symphony part is it's compatible with existing tool chains. So you'll see some of these demos when we go in, but it's also really important to keep our blockchain infrastructure compatible with existing tool chains, because when enterprises start building on top of VideoCoin or start using VideoCoin, it's really important for them to have easy access to developers. If we build something really complex that nobody can use and start making our own tool chains that we need to maintain, it's a ramp-up curve for our customers and developers, which will take longer time for the community to pick up application development and do something productive on VideoCoin. So this is a brief, very high-level overview of what VideoCoin Symphony is. And this is a perfect time for me to hand it over to Ricardo, where he can go over in depth of the architecture of VideoCoin Symphony and explain our architecture choices here. So Ricardo, do you want to take over?
Yeah, thanks, Deva.
Stop sharing this device.
So as Deva said, one of our main goals was to provide an API for public key usage. That was one of our main goals, and basically we had two goals in mind. One was to provide an API, and the other one was to use the first version of VideoCoin's official implementation, which is currently based on Ethereum. We're talking about a scalable and portable API, and basically there's a lot that goes into it, and basically this image gives us an overall view of the project. I'll start with the blockchain elements. So in order to serve all the API requests, probably you know right now one of the most used services in the blockchain space is probably Infura. As Deva said, there are lots of projects that don't want to maintain infrastructure because first you need people to do it, and second, it's very complex and there's usually a lot of context that goes into it, so it's very expensive as well. So we wanted our own way of providing something simple, and that would allow developers just to focus on development of features without worrying about all the infrastructure that goes behind it. So that's what we have been focused on. Right now, as you can see in the image, we basically have an endpoint, which is the RPC API. Right now, it's we have a set of archive nodes that are serving the requests. The interesting thing about this is that all our infrastructure is scalable. So as soon as we start getting more requests, our infrastructure will be able to handle that situation automatically by adding more archive nodes. Just for reference, archive nodes is basically a node that is just storing the blockchain data. It doesn't take part of the consensus node. Its only purpose in our infrastructure is just to serve requests. Yeah, so there's a lot that goes into providing an API. Mainly architecture-wise, our network is composed by a set of miners, a set of archive nodes, and boot nodes that allow any node and future clients to connect to the network. Right now, our alpha is, right now you won't be able to connect to our network. We're still, although we have this version available, it's still not open to public yet. But yeah, regarding the network, yeah, we also have an internal faucet that we use to fund our accounts and for our testing, and we'll talk a bit more about that later on, as soon as we discuss the flows that users can execute in order to get access to all these features. And it's important to mention as well, and that's, as David said, one of our main objectives is to use the existing tooling with our API. So we're taking that in consideration, and right now you'll be able to use frameworks, very popular frameworks such Web3, Truffle. We'll have a demo about that in a minute. So that was also very important in taking all this into consideration. Just to, yeah, so we covered the blockchain part with the boot nodes, miners, archives that serve RPC requests. We talked a bit about the faucet, and now I want to focus a bit on the security part, because it's probably the most important thing. Well, it's the most important thing in a blockchain project. And yeah, we're using a couple of technologies, mainly standards nowadays for infrastructure that help us secure our keys, and as well as all the security around the infrastructure. Just as a use case, something that we actually developed in the past couple of weeks. Just to give you one example, is the usage of HashiCorp's Vault. Basically, the main motivation for it is that unlike banks, we cannot revert transactions. So it's really important to keep everything safe. And that's why we are using a private cluster for securing our secrets. And a different use case, as an example, is API-wise. In terms of security, we are restricting certain methods. We have discussed this in the past. Probably one of the most common attacks in the past was that, and this is related to infrastructure. There were a lot of people trying to build their own infrastructure, but they would not create the right configuration. And what happened is that they would open several network ports, and hackers were actually able to move funds at their will. So we are going to discuss next and we are going to present some of these security features that we have in place, such as authentications, method filtration, and as well as identity verification for the current alpha. So just to finish, we talked a lot about the API. The other goal was to focus a lot on VideoCoin's protocol implementation, so the official clients. So right now, just to give you a brief summary of the main points of the clients. Right now, we're using our client is based on Ethereum. Go Ethereum client, Geth. Right now, both repositories for infrastructure and for the client are private, but we'll share more details about that in the future. Since we are still currently testing all the features. And yeah, the Vid client is going to be the main access point. I mean, if you are a developer and you're interested in developing, you can use existing tooling such as Scalable. So you probably don't need to care about this point. But if you want to contribute and if you want to run your own nodes in the future, you'll be able to connect to the network using VideoCoin's clients. So that's about it. We have been putting a lot of focus on a fully scalable automated infrastructure, and we have been focused on our official client implementation, as well as the foundation behind, such as continuous integration. So the first few pillars of the whole infrastructure. Yeah. Would you like to add something else, Devon?
Yeah, no, thank you, Ricardo. I think that was a great overview. So I think the main thing here, what Ricardo and team have built here is about the infrastructure itself is highly scalable, right? Like it works right now for our alpha purposes, but as we scale our blockchain, as we get more and more customers, the infrastructure itself scales along with it, and we don't have to anything from a few hundred transactions per day all the way to a billion transactions per day. We should be able to handle it through the same infrastructure and the same development that's going on. And this becomes very important for end consumers and enterprises as they access our blockchain network. This interface will become the primary way people use the blockchain. So this is a really important part of the work that we've done. So I think at this point, we'll go over a demo. So Jonathan, do you want to take us through the demo?
Of course, Deva. For me, it's a pleasure. We are very excited. So let's go to the demo. Let me share my screen. Basically, the main idea here is to keep it simple, okay? And we know that there is a lot of complexity behind, but the most important is that it's very usable. So let me share my screen. Okay, we have faced some things that we needed to take care about, not only about scalability, that is the part of the infrastructure that we have seen, but from the point of view of security. I mean, we cannot expose some methods, we cannot expose our network like if it was something that we shouldn't care. So we have built 3 layers of security. If we go back to the end-to-end presentation that we see, there is a sign-up process just to get ready to test the alpha. So one of the things is that we cannot access the RPC if we haven't signed up before. Okay, so here we can see a simple call, an RPC call. We call from the outside without having any key, without having anything. We will get an unauthorized, no secrets here. So let's see. Now we have signed, okay, and we call the same network, but this time with a token that we have received after we have signed up. In this case, we get the results. And the second security layer that we have we have provide here is address. We cannot create transactions if we haven't signed up before. So our address from the moment that we sign up, the address that is generated is put on a whitelist. Okay, so we can see an example. Now we try to execute a transaction, but our address for some reason has been created locally, and we have not. It's not part of our alpha network. We call it, and surprisingly, this address is not allowed. So thanks God, security is one of the parts that we take care. And this brings us to a third layer, not less important, because we have seen, as Ricardo has said before, a lot of attacks that a lot of project has received is because a node was not configured properly. So imagine we have a node, we have put this node live, but we have set our private key out there. It's just easy as calling like a send transaction method, and we send the funds to us. But well, this is a professional and important thing that we take care, and we have filtered a lot of these methods that we have seen are very dangerous to expose. This is an example, the unfamous send transaction. If we call it right now directly, we will see that it's not allowed. This method is not allowed. But this doesn't happen with methods as safe as to get information about the syncing. So this one that we called before, we get a response. Remember that we are exposing an RPC, and this brings another of the nice features that we can use all existing frameworks, just like Truffle, something that is out there ready to work on the VideoCoin network. I don't know, Deva, if you want to say something more about it, or we can give the honor to Adrian to work on
I think it's a great demo.
Truffle.
Thanks, Jonathan.
Thank you.
Yeah, so again, like Jonathan made it look super simple, but the amount of work that has gone in to get all of these 3 layers of security in, and also getting everything to seamlessly work is a lot of work. Right? Like if the video that Jonathan was talking about was our end-to-end demo, where we showed how you can create an alpha account and get that approved and wait for getting a wallet that you can use with the network. So all of that happens in a different place, and that is seamlessly integrated into our infrastructure network, and we have 3 layers of security on top of it. So and we, in hopes of keeping this network as secure as possible and not exposing it to trivial attacks, or at least based on at least 3 layers of security should allow us to protect even from complex attacks, I hope. All right, so like now the complexity, let's simplify that even further by looking at how to use existing tool chains. And Adrian here is going to take us through how easy it is to use some of our existing tool chains. So Adrian, do you want to take over?
Yes, of course. And thank you, Dave and Jonathan, for the nice introduction. And one of the existing tool chain tools that we are using for development of the smart contracts is Truffle framework. For those of you that doesn't know what the Truffle is a framework for the smart contract development, which is up there and speeds up the development of the smart contracts for the Ethereum network. It's very widely used among other Ethereum smart contract developer, and we loving this tool internally, and we wanted to also be able to integrate it with our network. So just to show you the integration, let me just share my screen, my terminal. Okay, great. So currently I'm in a smart contract folder, and from this point, I will show you that we use the Truffle to migrate all of our existing smart contracts. And I will try to deploy them again, but smart contracts are already deployed. So we should see a message in a minute that network is up to date. If no, then we will see on the demo that the migration is being done. But wait a second. Yes, we get a message that the network is up to date. But what other thing that we can do with Truffle is use a Truffle console and connect to the RPC node that Jonathan presented a couple of minutes ago. And from that Truffle console, we'll access one of our smart contracts. And one of those smart contracts is a stream manager. Stream Manager has a couple of functions, which I don't go much details into, but one of the things and methods that he has is a validator that we can check if the current address is a validator or not, and add a potential validator to our Stream Manager. But first, I will check the Stream Manager address. And what I'm gonna do right now is to create an instance of the Stream Manager, so I can access all the methods. Yes, Stream Manager, add the address that I just copied. Here we go. One more thing that I need and just copy for the later is the get accounts. Yes, this is the account that I'm currently using, and I will add it as a validator. But first, let's call our smart contract, the isValidator function, and check if the current address is a validator. It should say false. Yes, it says false. That's great. That means that we can add validator right now. And in a minute, we should see a transaction being made. Yes, great. The demo gods are with us today. And I believe that would, one more thing, because yeah, we added a validator, but we can check again if the validator was properly added. And yes, we can see that the isValidator function that previously returned false and now returns the true. And that's just a short demo of the Truffle. We use it for the migration of our smart contracts. We use it for internal testing of our smart contracts, writing the unit test and integration test. And also we can use Truffle console just to get access to the RPC and testing on the live network and call some of the methods on the smart contract that I just did. So, Deva?
Cool. Thanks a lot. That was a great demo. Thanks, guys. It was a really good demo. So, again, Adrian touched on a few parts of the VideoCoin protocol. So the protocol demo is the next one that we're going to show, of which Adrian will also be a part of, and we'll show you in depth how the exact protocol works. Some of the calls that Adrian talked about here may not make sense now, but if you watch our protocol demo, it makes a little bit more sense, I think. So the end-to-end demo that you saw in the first video that we put out, it was using the protocol, using the infrastructure that we put together here to access the protocol and finish the transactions and complete escrow payments. And it's a pretty detailed protocol that we will get into in the next video. But that's it for us. Thank you so much for watching this video, and then stay tuned on our Medium channels and Telegram channels. Thank you.
Thank you.
Thank you.